Every morning, millions of Americans pour milk over those golden little O's without ever wondering about the engineering marvel that created them. But here's a question that will change how you see your breakfast forever. How do you transform humble oats and liquid honey into perfectly crunchy rings that somehow taste like childhood memories? What you're about to discover isn't just another cereal production line. It's a billion-dollar operation where temperatures are monitored to the exact degree, where honey is applied with scientific precision, and where a single miscalculation could turn 50,000 boxes of cereal into expensive bird food. Because the real secret isn't in the honey or the oats. It's in a 900-degree furnace that puffs each grain in exactly 4.2 seconds. And a flavor coating process so precise, it makes pharmaceutical manufacturing look simple. Today, we're taking you inside one of General Mills' most guarded facilities, where 24 hours a day, 365 days a year, machines transform 2.5 million pounds of oats into America's most beloved breakfast cereal. We'll reveal why these golden rings require more engineering than most cars, how real honey survives temperatures that would melt copper, and why one tiny bee mascot became worth more than some small countries. So grab your spoon. We're about to dive into the most deliciously complex manufacturing process in your pantry. Our journey starts in the rolling farmlands of Minnesota and Wisconsin, where specially contracted farmers grow what General Mills calls premium milling oats. But these aren't just any oats. Each batch must pass 47 different quality tests before they're even allowed near the factory. The oats arrive at the facility in massive silos that can hold enough grain to make 12 million bowls of cereal. And here's where the science gets fascinating. These oats undergo a process called conditioning, where they're exposed to precise amounts of steam and heat to achieve exactly 14% moisture content. Why 14%? Because at 13%, the oats won't puff properly. At 15%, they'll explode instead of expanding. This single percentage point is the difference between perfect Cheerios and expensive compost. The real magic happens in what engineers call the de-hulling chamber, where each oat kernel is cracked open using a process so gentle it would make a watchmaker jealous. The hulls are removed using a combination of air currents and vibrating screens, leaving behind the pure oat groats. These groats are then ground in massive steel mills that spin at exactly 1,847 revolutions per minute, fast enough to create flour, slow enough to preserve the oats' natural oils that give Cheerios their distinctive nutty undertone. Here's something that will surprise you. The grinding process generates so much heat that the flour must be immediately cooled using liquid nitrogen, or it would start cooking before it even reaches the ovens. In gleaming steel mixers, the size of small rooms, the oat flour meets its destiny with water, salt, and a secret blend of vitamins that transforms ordinary grain into nutritional powerhouse. But this isn't your grandmother's bread dough. This mixture has the consistency of thick paste and must be mixed for exactly 12 minutes and 30 seconds. The dough then travels through what looks like the world's largest pasta machine, a series of steel rollers that flatten it into sheets exactly 0.8 millimeters thick. Any thicker and the O's won't cook evenly. Any thinner and they'll shatter during the puffing process. Next comes the moment of truth. The cutting process. Diamond-sharp dies punch out thousands of tiny O shapes every minute, and each die must be replaced after exactly 2.3 million cuts, or the edges become too dull to create clean holes. Then those little dough O's you see tumbling down the conveyor belt are heading straight into the puffing furnace. Welcome to the most intense 4.2 seconds in breakfast cereal manufacturing. The raw dough O's enter a furnace heated to exactly 900 degrees Fahrenheit, hot enough to melt aluminum. But this isn't just about heat. It's about creating a controlled explosion inside each tiny ring. As the moisture inside each O rapidly turns into steam, the internal pressure builds until the dough literally puffs up like a microscopic balloon. The timing is so critical that sensors monitor each batch 200 times per second, adjusting temperature and airflow to ensure every single O puffs to exactly the right size. But here's where it gets truly wild. If even one O doesn't puff properly, it can jam the entire production line, shutting down a system that produces 50,000 boxes per hour. The puffed O's emerge from the furnace looking like tiny golden donuts, but they're still not Cheerios. They're too bland, too plain, and definitely not honey-flavored. That transformation happens in what General Mills calls the flavor chamber, and it's where breakfast dreams come true. Here's where things get deliciously complex. The honey coating isn't just honey, it's a precisely engineered blend of real honey, natural almond extract, sugar, and a secret ingredient that General Mills guards extremely carefully. The coating process happens in massive rotating drums that look like cement mixers, but operate with the precision of Swiss watches. As the plain Cheerios tumble inside, atomized honey mixture is sprayed through 144 different nozzles, each one calibrated to deliver exactly 0.003 ounces of coating per O. But here's the critical challenge. The honey mixture is heated to 180 degrees to keep it liquid. But if it's too hot, it caramelizes and turns bitter. Too cool, and it won't adhere properly. The temperature window is just 8 degrees. The real genius is in the adhesion science. Each Cheerio spends exactly 47 seconds in the coating drum, tumbling at 23 RPM while warm air circulates to help the honey penetrate the puffed grain structure. This creates what food scientists call flavor lock. The honey doesn't just coat the surface, it actually bonds with the oat proteins. And that distinctive almond flavor? It comes from just 0.2% natural almond extract, but it's applied using a process so precise that each O receives exactly 847 molecules of almond flavor compounds. Fresh from their honey bath, the coated Cheerios enter what looks like a wind tunnel designed by breakfast engineers. This 200-foot-long drying chamber uses precisely controlled airflow and temperature to remove excess moisture while preserving that perfect crunch. The Cheerios travel on perforated conveyor belts while heated air flows upward through the holes at exactly 165 degrees Fahrenheit. Too hot and the honey burns. Too cool and the Cheerios stay soggy. The entire journey takes 8 minutes and 15 seconds, enough time to reduce moisture content from 12% to exactly 3%. But there's a hidden challenge here that nearly destroyed the entire Honey Nut Cheerios project in 1979. The honey coating was causing the O's to stick together in massive clumps. The solution? A final dusting of rice flour so fine it's invisible to the naked eye, applied using electrostatic charges that make each particle cling to the cereal like microscopic magnets. Before a single Cheerio leaves the factory, it must pass what General Mills calls the crunch test. In a soundproof laboratory, technicians use calibrated microphones to measure the exact decibel level of each batch being chewed. The target? Exactly 73 decibels, loud enough to satisfy, but not so loud it wakes the neighbors. But the testing doesn't stop there. Every hour, samples are tested for honey distribution, using spectrographic analysis. Crunch duration, must maintain texture for exactly 4 minutes in milk. Flavor intensity, measured by trained taste panels. Shape consistency, photographed and analyzed by AI. Here's something that will blow your mind. General Mills employs professional cereal tasters, whose job it is to eat Cheerios all day and detect flavor variations as small as 0.1%. Word on the street is that their taste buds are insured for $1 million each. The packaging line moves so fast it's almost hypnotic. 1,200 boxes filled every minute in a ballet of mechanical precision. Each box is formed, filled with exactly 12 ounces of Cheerios, sealed with a liner bag, and closed in just 2.3 seconds. But here's the hidden genius. The boxes are filled using a volumetric system that accounts for the settling that occurs during shipping. What looks like a not quite full box is actually precisely calculated to be exactly 12 ounces after the Cheerios settle during transport. The inner bags are flushed with nitrogen to prevent staleness, and each box is date-coded with information that can trace it back to the exact minute it was produced, the specific batch of oats used, and even the individual nozzle that applied the honey coating. This single production line produces enough Honey Nut Cheerios every day to fill 847 school buses. In a year, that's enough to create a trail of cereal boxes stretching from New York to Los Angeles and back again. The little bee mascot buzzing around your cereal box? He represents one of the most successful food marketing campaigns in history. Buzz Bee has been the face of Honey Nut Cheerios since 1979, and his image is now worth an estimated $2.3 billion in brand value. And here's the fascinating part. Buzz Bee's design has been scientifically optimized for maximum appeal. His yellow and black stripes trigger positive associations with honey and nature, while his friendly expression activates the same brain regions associated with trust and comfort. In focus groups, children who see Buzz Bee on the box rate the cereal as 23% more delicious than identical cereal in a plain box. That's the power of breakfast psychology. While Americans enjoy their classic Honey Nut Cheerios, other countries have fascinating variations. In Canada, they're slightly sweeter to match local taste preferences. In the UK, they're called Honey Nut Loops and contain 15% less sugar. Japan offers a green tea honey version. And here's something that will make you appreciate your next bowl even more. The entire process, from raw oat to finished cereal, takes exactly 6 hours and 42 minutes. But each individual Cheerio experiences temperatures ranging from -10 degrees during nitrogen cooling to 900 degrees in the puffing furnace. That's a temperature swing of 910 degrees, more extreme than the surface of Venus. So the next time you pour those golden O's into your bowl and hear that satisfying cascade of crunches, remember, you're not just eating cereal. You're experiencing the culmination of 40-plus years of food engineering, where every ring has been puffed, coated, dried, and tested with scientific precision that would make NASA jealous. What's your go-to cereal? Are you Team Honey Nut Cheerios, or do you have another breakfast favorite? Drop it in the comments below. And if you learned something new about your morning routine, hit that like button and subscribe for more behind-the-scenes food science that'll change how you see your pantry forever.